Welcome to the DD1324 online lectures. In this lesson, we'll cover pointer basics. In order to understand pointers, we must first understand how computers store various data types and variables to memory. In RAM, each byte of memory has an address, and the memory addresses each contain one byte of memory and are ordered sequentially. Here we can see the addresses are on the left, and the contents of the memory are on the right in this diagram. When you make a declaration in your program, the computer allocates some amount of memory corresponding to the type that you declare. For an int, it usually takes 4 bytes, for a char, 1 byte, for a float, 4 bytes. Here we declare an integer a. The computer knows that because a is an integer variable, it needs to allocate 4 bytes of memory. It starts this allocation at memory address 207 and ends it at 210. Internally, the computer stores information such as there is a variable a, it's an integer, and it is located at address 207. Note that while allocating the memory, the computer did not overwrite the previous existing data in the computer's memory. Now if we declare another variable, a char c, we can see this char c occupies 1 byte at address 212. Now if we assign a value to a variable, it overwrites the memory at the address that it was assigned to. So here we said a is equal to 5, and in the memory address 207 to 210, we can see that the bytes here have been changed to represent the integer 5. By incrementing the value of a, here we have a new line a++, this causes the machine to overwrite the memory at address of a with a new value. So here you can see now in address 210, we have a value of a equals 6. Pointers are a special type of variable that stores the address of another variable. In this example, we make a pointer variable p of type pointer to integer, which stores the address of the integer a which we declared previously. Using the properties of p or other operators, we can then reach a. Here you can see where we declared a, an integer with type int. In this line, we're declaring p, a pointer that points to an integer. The declaration format for pointers is you always give it first the type, and then a star, and then the identifier. So the type is an integer, the star means it's a pointer, and p is the identifier. In the next line, we're assigning a value to p. In this case, the value of p is the address of a. The ampersand operator gives us the address of another variable. In this case, it's the address of the integer a. So, the pointer p has its own memory location. In this case, it's location 64, and it also has a value assigned at that memory location. And that value is the address of the integer a, the address 207. So it's pointing to the address 207, which contains the data for the integer a, the value of 6. Now, if we were to declare another integer variable, the integer b, and assign it the value of 10, this might get created at address 128. And we could also change p so that it points at b by saying p is equal to the address of b, ampersand b. And in this case, the pointer will change from being 207 to 128. We can use printf statements to check that the value of p and the address of b are the same. The %p is a special formatting for the printf operation that allows us to print the address of a pointer. So here if we say printf of p, we can see that it has the address in hex 0080 or 128, and here we can print the address of b, and it's also 0080 or 128. Just pointing at addresses by itself is not very useful, but we can use pointers to obtain the value at the location where they point by dereferencing the pointer using the star operator. To get the value of where p points, you can use the syntax star p. So here you can see, to print the value of b using the pointer, we can dereference it using the star operator. So printf b equals, and here we have a %d because we want an integer, and we use the dereferencing operation on the pointer, and that gives us b equals 10. We can also change the value at some location in memory that's pointed to by a pointer in a similar manner by using the star operator. So for example, here we can say star p equals 8, or the location that p is pointing should now contain the value 8. And so when we do that, we see that the address of P is 128, and so the program updates the memory at 128 to contain the value 8. So now if we run a printf statement here on star P, we get a value of B equals 8. So by doing this operation, we've changed B from the value of 10 to the value of 8. Before we proceed further, it's worth discussing briefly about style when declaring pointers. Programmers may use different styles when declaring a pointer by varying where they place the star operator. The following styles are equivalent, and using one or the other is a matter of taste. In this first style, which emphasizes the type of the pointer variable, the syntax says that you begin with the type, and then you place the star, and then you have a space, and then the pointer identifier. In this style, it's saying the type of the pointer is a pointer to some type. The second style emphasizes the type of the pointer to data. Here, we begin with the type, and then a space, and then a star, and then the pointer identifier. In this case, we're saying the type of data pointed to by the pointer is some type. Both of these styles mean the same thing. You can also put the star in the middle, which is another convention that avoids committing to either. Another important thing to note is that pointers are strongly typed, which means that you must declare pointer variables with the appropriate data type. For example, if you want the pointer to point at an integer, you need to declare it with an int star. If you want it to point at a char, you want to declare it with a char star, and floats with float star. This is because we not only use the pointer to store the address of the variable, but also to dereference it and modify it. And in order for the program to know how the data is stored and to be able to modify it properly, it needs to know the formatting and the amount of memory it consumes. This information is given by the type of the variable. It's also possible to do basic arithmetic on pointers to change the address to where they are pointing. Let's look at the following example. Here we begin by declaring an integer a with a value of 1025 like before. We then declare an integer pointer p which we say points to a by assigning it the address of a. If we do a printf statement on the by dereferencing the pointer p with a integer format, we get the following 1025. So it looks at the contents of 200 through 203 and it finds that this gives us a value of 1025. In the next line, we print the location where P is pointing to, and we say it's the memory address 200. If we say P plus 1, it knows because it's an integer data type, an integer pointer data type, that it has to add 4 bytes to the pointer value to move to the next integer here. So when we say P plus 1 here, we get a value of 204. And now if we want to look at the value of what's contained at P plus 1 by dereferencing that pointer, we can do that by doing printf of %d, which is looking for the value of what's dereferenced by star P plus 1, and it's some crazy integer, which is probably because this memory over here has been used from some other part of the program, and it hasn't been initialized or set with any value that we declared. Now we can do another interesting thing, is we can declare another pointer. In this case, it's a char pointer. So char star q is equal to p. So we've given the same value, the same address pointing from p to the pointer q. So they're both pointing at 200. So here, if we print the value by dereferencing q, instead of getting 1025 like we had before, this time we get a value of 1. And that's because the char star pointer is only looking at 1 byte of data, so it's only looking at 200. So when it's looking at this, you can see here in binary, this has a value of 1, and so we get a value of 1 here. Now we can check to make sure where it's pointing, and we can see that indeed it's pointing at 200. And we can also do the same trick that we did before. So this time we can increment the pointer by 1, and in this case, instead of moving to 204, it moves to 201 because char data types use only 1 byte, so it moves to 201. So now when we do another printf with %d and we dereference the pointer at q plus 1, we get the char readout for this byte here, which you can see is 100, which is 4. This concludes our lesson on pointer basics. Thank you for watching.